In the SR flip-flop, if S is 1, R is 1, then output of the NAND gate 1 and 3 will be 0 and any one of the input is 0, output will be 1. But this condition is avoided or prohibited in the SR flip-flop. Therefore, this condition is satisfied in JK flip-flop. The circuit is same like SR flip-flop. Only the feedback of Q and Q bar is applied to the input NAND gate 3 and NAND gate 1 respectively. So in this case, if J is 0, K is 0, the output will be 1. And then based on the feedback, same like SR latch, the output will be generated. In the second case, if J is 0, K is 1, then this will be 1, this will be 0. Accordingly, based on the feedback again, same like SR latch, output will be generated. The third case, if J is 1, K will be 0, this will be 1, this will be 0. Same like again SR flip-flop. I mean to say SR latch, the output will be generated. Now see the main condition, J is 1, K is 1. As I mentioned here, J is 1, K is 1. So based on this feedback, the output will be generated. Initially I assume Q is 0, Q bar is 1. Then output of the NAND gate 3 will be 1. Output of NAND gate 1 will be 0. Then any one of the input is 0, output will be 1. And this will come to the input of NAND gate 4 and output will be 0. So we are getting the inversion of the previous state. So previous it was 0, we are getting now 1, and it was 1, we are getting now this is 0. So the condition of J and K both are 1 is solved in this JK flip-flop. See the truth table. If J is equal to 0, K is equal to 0, there is no change in the state, then output will be 0. This is reset condition. If J is 1, K is 0, we are getting output 1. So this is set condition. If both inputs are 1, then we are getting Q n bar and Qn as inversion in the result. But this condition is called as a toggle condition. This is JK flip-flop which works on this clock signal. So this clock signal may be level trigger clock signal or edge trigger clock signal. We are assuming this is level trigger clock signal. So this is clock signal which has T on period and T off period. And if this T on period is maximum than TP period, so TP period is a propagation delay of this JK flip-flop, which means that on the activation of the clock signal, the circuit takes some time to produce the output. So this is processing time. So that is nothing but the propagation delay, and this delay is less than T on period. And if J is equal to K is equal to 1, means both inputs are 1, then race around condition will be occurred. So what is that condition? This is clock signal. Then output of this flip-flop will be fluctuating between 0 and 1, since the feedback is taken from Q and Q bar to the input side. And if the T on is maximum than the propagation delay and the circuit works on the level trigger clock cycle, so we are getting the fluctuations in the result between 0 and 1. So this condition is nothing but the race around condition. SR latch. This is R with clock signal. So we have done some changes in the circuit. Means we are taking the feedback Q to this input and Q bar to the first input. So the circuit will be converted into the JK flip-flop with clock signal. So to avoid the race around condition, we are using the master slave flip-flop. So this is master and this is slave. So this is JK flip-flop. This is SR flip-flop. The first circuit works on the clock signal, and inversion of the clock signal is applied to the second circuit. This is C and this is C bar. If both inputs are 1, then the result depends on the feedback signal. If this circuit is activated, J is equal to 1, K is equal to 1, during this period, the second circuit will be in off state. And the result or feedback we are getting from the Q and Q bar. Based on that, the first circuit result will be generated, and during the next inversion cycle, the circuit will be off and this will be in on state, and accordingly the result will be generated. So this way the fluctuations between 1 and 0 at the output of this flip-flop is avoided by taking master and slave flip-flop. So this is master flip-flop, this is slave flip-flop, and both are works in inversion mode, means this is clock signal, this is inversion of the clock signal, and this way the race around conditions is avoided in JK flip-flop. Next, the D input is applied at the J terminal and inversion of D is applied at the K terminal. Then this type of flip-flop is called as D flip-flop. Okay. If this input is applied at the both J and K terminals, or both terminals are short circuited and at the same input level, then this type of flip-flop is called as P flip-flop or toggle flip-flop.